Welcome to lecture 12, and in this lecture I'm going to explain the second piece of coursework for this course, which is the data visualization website. So I'm going to start with an introduction, give you some background to cloud computing, motivation for it, all that kind of stuff. Then I'm going to go into the coursework I'm asking you to do for the spring term. I'll give you some examples of websites that are kind of similar to the coursework that I'm expecting you to build. Go into some of the data sources you could use for your project, explain how you submit your project, and how it's going to be assessed. So, those of you who did my course last year, and also those of you who joined the course, I'm sure that all of you are very capable of building websites based on a single server running Node.js or PHP or whatever. So those of you who were with me last year learned how to build an e-commerce website based on PHP, and you also learned to build a single-page web application using Node.js, and even your game website was running on a server, right, which was executing the PHP code. So it's like a single machine, single server, and in your projects, the server is connected to an SQL or NoSQL database, also running on the same machine, or could even have been on a different machine. And this kind of approach is great, for a sort of for a website that's maybe not having much traffic, few hundred hits, probably up to a few hundred hits a day, probably not per second, but say up to 10, 20 hits a second, something like that. But when you want to build up to a website that has millions of users, it can be quite difficult to scale the sort of single server, single database website up to a scale at which it can actually serve large numbers of users in a reasonable time. So if you want to scale up your very sort of basic website running on a single server with a single database, you need to do that by throwing more computing resources at it, right? So you need more physical machines, more CPU, more RAM and all that. And when you've got more physical machines, you can then put your server code onto multiple machines and have different machines handling different requests. And then you've got the rather tricky problem of trying to make your database run more quickly, and the only way you can handle thousands of requests per second on a database is by running it on several copies of the database on multiple machines. And this creates the problem that you've then got to split the data in a sensible way, and with SQL databases, they have very tight relationships between the data in different tables, so that's kind of tricky, and you can split the rows up maybe, but it's not such an easy problem to split up a database that's implemented on a single machine into a database on multiple machines, this whole sort of issue of sharding. And that's part of the motivation for NoSQL databases, which are easier to divide across multiple servers. And then you've also got the problem, if you want to scale up your website, that it takes quite a long time for a server to sort of receive the request, look up some stuff in the database, wrap this database stuff with, HTML and CSS and all that, and then return it back to the client. So to speed all that up, people traditionally have used things like Varnish, I think probably Squid as well, which is a sort of super fast machine that stores a cache of the rendered web page and then just can serve it up really quickly in response to requests without all the calls to database and all the kind of processing of data from the database. The caching is often used as part of the whole scaling thing, and then you probably have a separate server, separate physical machine to actually run the caching software. And this is certainly, the kind of architecture that Trinity Mirror, when I worked at Trinity Mirror, were using. And when I worked at Trinity Mirror, they had the cold room, right, filled with these servers. So, prior to the cloud, this is the way companies ran their websites, all their web stuff. They had large racks of servers. So server in this case means a physical machine that's carrying out things like running databases or running the actual server code on Node or Apache or whatever. So these are sort of physical machines, but they're designed to be put in racks, and so they're typically called servers. So traditionally, companies run their websites and all their other databases and all that, all the enterprise software, on large racks of servers on their premises. So it's a big room, or whatever, it's a room with all these kind of servers and these racks and these cupboards, and the room's kind of air conditioned, and usually it's extremely noisy. These servers aren't built to be like quiet, running on a desktop kind of thing. They're designed to be as fast as possible and efficient as possible, so they typically make huge amounts of noise with all their fans and all this kind of stuff. So big cold room full of servers and lots of noise. Now this kind of approach is sort of kind of easy to get started with, but it has lots of problems. So computers fail, yeah. So these machines, they break, yeah. And if you're a company, you're only going to have like maybe have a limited amount of redundancy in these machines. And also where you hold the servers, the server room, that can be flooded, it can burn to the ground, so on and so forth. People can steal your servers. So if you're doing this kind of server room approach, you have to back up your data regularly and distribute it to separate physical locations. So you've got to have some kind of synchronization script, possibly versioning, that copies everything from your servers onto another physical location, because the physical location is always going to be compromised, at some point. Servers also have the major problem that they're expensive. These kind of high-grade machines are much more expensive than standard desktop computers. And you've got the whole problem of maintaining these servers. So these servers are being hit constantly by attacks from the internet. So you've got to patch them with the latest patches. You've got to, maybe install some new hardware at some point. When the hardware fails, you've got to pay someone to kind of, fix that hardware and migrate the software onto different machines and so on and so forth. Yeah. So it's an enormous amount. It's very expensive to hire and pay people to do these kinds of jobs. Yeah. It's also very difficult to figure out how many servers you're going to need. So suppose you're sort of the manager of a company, sort of medium-sized company, and you've got to figure out, how many servers do I need in 2 years' time? Yeah, and obviously it's not just the servers; it's the people to maintain the servers, and it's also the physical space you've got to find and pay for. So if you think you're going to double your server capacity and your server room's packed solid with servers, you've got to find another server room, right? Or change your office space, all this kind of stuff. So if you're a company and you're in charge of a company, you've got to predict, what your likely demand on your website and your other computing resources is going to be in the next 2 years. And if you get it wrong, it's going to cost you money. Yeah, if you get too little computing hardware, then you're going to be in a situation where your customers aren't going to have the rapid service they're expecting. There can be big delays in serving up web pages and so on and so forth. Or if you overestimate and you get too much hardware, then it's just going to sit there doing nothing and costing you money. Yeah. So you need to get it right, but it's actually really hard to get right. Suppose you have a new marketing campaign and you say, well, that's going to bring in 1 million new customers, so I better buy some new servers. But suppose the marketing campaign's really rubbish and you're selling new products, then that's just going to be wasted money buying all those servers to support the marketing campaign. Or on the other hand, if you have a sudden surge in demand, and that you didn't predict, then again, you're not going to be able to serve your customers efficiently. So you need to get it right, and if you get it wrong, it costs you money. So because of all these problems with physical servers on your company's, in your company's office space, that's one of the main drivers that's pushing people into the cloud. So a good way of addressing these problems is to move your website hosting into the cloud, move your database into the cloud. And this approach, as I'm sure you're very well aware, you have companies building warehouses that are actually packed with servers. These servers, some of them may be high-grade servers. The sort of cloud approach Google pioneered was actually using commodity hardware, yeah? So I think it's commodity hardware. It's kind of like hardware that's kind of cheap. It's not engineered to be massively reliable. They just factor reliability into the way in which they use that hardware. So cheap hardware, often with these kind of cloud server farms. And the great advantage of building server farms in a dedicated way is you can put them where labor and electricity and land is cheap. So if you have all your servers located in a London office, then you've got to pay a huge amount of money for that office space within London. Whereas if you put your servers in the Midlands, let's say, then land is going to be a lot cheaper. And also the people who are going to be maintaining your servers are going to be expensive to hire in London because of all the associated costs of living in London. Whereas if you put your server farm in the Midlands, again, it's going to be cheaper. And also in some cases, you can also, put your server farm somewhere where electricity is cheap, or you can, take advantage of certain cooling solutions and this kind of stuff. So you build your server farm somewhere where labor and electricity is cheap, and you hire a dedicated team of engineers to configure the software, manage the backup, etc. So you're going to get a real scaling advantage here, yeah? Because if you're a smallish company, you've got 20 servers, you've got to hire one person to look after those 20 servers, then, that's not great. But it doesn't cost much more to maintain, 200,000 servers, right? It costs more, obviously, because it's more complicated, but you can just replicate your software across all the multiple machines. You can have an automated patch run out system, so you can actually maintain a lot more servers more efficiently when you've got economies of scale. And economies of scale also apply to buying the hardware itself. If you're buying your servers, then you're going to pay, a small unit, high cost, because you're only buying small numbers. Whereas if Amazon's buying 400,000 servers, they can get them pretty cheap. Yeah. So it's big advantages to this kind of server farm approach. And then once they've built the server farm, then the company like Amazon, Microsoft, whatever, then they hire out the servers or the services. So, you can actually probably hire a real physical machine on Amazon if you really wanted to. Or more realistically, you might get a virtual machine, which can be switched in and out, depending how much you're using it. And they might have hundreds of virtual machines running on a single physical machine, or, in some ways much better, you can actually hire out services, and the coursework we're going to focus on is more of a service approach than just getting a physical machine in the cloud kind of thing, which isn't particularly interesting. Whereas you have a service approach, you can have like a database service, or you can have like a Lambda service, or a gateway service, or a image recognition service, and so on and so forth. So that's the kind of the better way of using the cloud, really, when you're using these services, which are running, who knows where, somewhere in the data farm in Ireland, for example. So, this is what they look like. It's an American example, I think. And obviously you can then take advantage of solar or local electricity generation or whatever, yeah, if you've got something that's that big. So the cloud's great in many ways, yeah, and if I was running my own company, I'd put my stuff in the cloud without any hesitation, I think, because it's flexible, right? So if you have a sudden surge in demand, then you can immediately use more cloud resources, right? And if you have your demand for your website suddenly goes right down, then it's very easy to use less resources. So if you look at the pricing models on Amazon, for example, they charge you typically for how much your software, how much time it runs for, and how many resources it consumes. Yeah, so it's a very dynamic model of pricing. So rather than buying a physical machine and paying for the electricity for that machine to just sit there running, Amazon will charge you for how long your code is actually running. So typically you can make big savings on that, as opposed to running your own servers. So you don't pay for an active code, you just pay for runtime of code. Now, you as a company, if you're using the cloud, don't have to hire and train staff with appropriate hardware and database expertise. You don't have to maintain your own database. You don't have to patch it whenever a new patch comes out and all that kind of stuff. And all the replication of data is done for you, often with versioning. So with S3, for example, you can create versions of objects. So you don't have the danger of overwriting working code with your new code that actually doesn't work, because you can just roll back to the earlier version. And they get you produce high levels of reliability, so Amazon claims 99.99%. And you can actually tailor the reliability of the stuff you're running. You can have control over it. You can pay for a more reliable service with the cloud typically, or I went to a talk a few weeks ago where they're explaining how usually Amazon you run within a particular region, which means you're tied to a particular server farm of some kind, which will be maybe 99.99% reliable, but then you can configure your system so that it'll run across multiple regions or server farms, so that you can then switch between server farms dynamically depending upon whether things are working or not. And clearly we've got the economies of scale, yeah. So we've got a small dedicated team of engineers maintaining 400,000 servers. Those servers are running where land, labor, electricity, and all that's cheap. So there's big economies of scale. So although Amazon takes its cut, it charges you for using all these services, it's almost certainly going to be cheaper than just running your own servers in your own office space. So a little analogy. I mean, suppose you had to generate your electricity. Yeah. So you got your house or flat, whatever. So first thing you've got to do is guess how much electricity you use. So you've got to look at your devices and measure the power in all these devices and say, well, I'm using this much electricity, and you've got to predict how much you're going to be using, in the next year or two. Are you going to buy an electric car, which is going to have more demand, or so on and so forth. So you've got to make some, do a fair bit of work estimating how much electricity you're going to use. Once you've done that, you can buy the appropriate equipment, right? And you maybe need to get redundancy, so maybe you need a generator and solar, whatever. You've got to maintain that equipment. Generator's not going to last forever. You've got to oil it and all the rest of it. And you've got to buy fuel for it. And all of this is an enormous amount of time, hassle, and money, yeah? Whereas what we actually do, because of all this time, hassle, and money, is we use cloud electricity generation, right? We pay someone, like a big electricity company, to build a huge generator somewhere or other, where labor, land, etc., and is cheap and the resources are available. And then that electricity company generates the electricity and sells some of it to us. And we can, if we need more electricity, it's easy to scale up because the electricity company's got lots of capacity. And if we need, and we only pay for as much as we use, right? If we need to use less, then that's not a problem either. And obviously, again, in the electricity example, if we're building an enormous nuclear power station or gas power station or something like that, it's going to cost an enormous amount of money, but that company is going to have economies of scale, right? It's going to need less people and less work to maintain and run it than it would if everybody did their electricity separately by themselves. So this electricity example, if it's not clear to you about the advantages of cloud computing, then think about the advantages of cloud electricity generation. So the cloud's not perfect, yeah? It's new. And we still haven't really figured out how to use it. So, I was listening to a biography of Turing last year, I think it was. And, which kind of went through the kind of development of the sort of early computers, right? So, when they first developed, digital computers, they really didn't know, how to use them. There was none of this, writing in a high level language and compiling down to, assembly or any of that. They just sort of, or the von Neumann architecture with the kind of memory and the CPU and all that. None of this was kind of clear at the time when they were developing these things. It was a sort of slow process in which the modern way of using computers, which we're all super familiar with, kind of came into being through lots of people collaborating and trying different approaches. Yeah, so it took a long time to get to the standard way of writing and running programs. And the situation now is kind of similar with the cloud. We've got all these enormous server farms with hundreds of thousands of machines running, and obviously we can run, we can already run our software in kind of different ways in that environment. But we're still trying to figure out the best way to do that, I think. And the people at Amazon are kind of frank about that. When I went to their day a few weeks ago, they were like, well, stuff's changing. We're still trying to learn what's the best way of building stuff in the cloud. How do you run something across 100,000 machines? And it's not just going to be a copy of the way in which you did it on one machine, right? There's new and better ways emerging for running stuff across large numbers of computers. So the serverless, approach is nice. I'm going to teach that in this course, and that's clearly going to be around for some time, but it may not be the final and end solution that we consolidate, kind of congeals out of all this in 20 years. Who knows what it would be. And so if you're working with a big cloud company, they put a lot of effort into duplication of data, reliability, and so on and so forth. So the cloud companies are likely to be more reliable than your own servers because they've got, top engineers working on that, yeah? But they're not going to be perfect, yeah? There could be a massive hack of Amazon and that wipes all of the data on all of the servers in some big server farm, and everyone would just lose their data. It could be, or steal all the data, all the data could be stolen, whatever. There could be some, an asteroid could hit Ireland's data center and blow it to bits. So there's always the possibility of failure and the possibility of massive failure of some kind. And another issue with the cloud is it's difficult to move data and code between cloud providers. So I'll cover the Serverless Framework in this course briefly, not in great depth, but that allows you to run the same serverless code on different cloud providers. But other stuff, may be dependent on the actual cloud, the actual offering of a particular cloud provider. So for example, if you're using DynamoDB on Amazon, then there may not be an exact equivalent on Microsoft Azure, let's say. So it might be quite difficult to migrate your project and your code from DynamoDB to something on Microsoft Azure or to MongoDB. So there's you are sort of tied in to some extent to what the cloud provider is offering, and they may change that, without telling you or any control that you have over it. There's big issues if cloud providers go bankrupt. I mean, a big one hasn't gone bankrupt, so no one's got really upset about this yet. But it may happen, right? If Amazon, let's say, goes bankrupt, then all of their servers might be sold off. You know, your code might be sitting on some of those servers, might not be encrypted, someone else might get access to it, so your data might be exposed. And obviously you're going to lose all the services, so you're going to have to somehow put your website back together on a different cloud provider, yeah? And it's possible that, you know, governments be able to access your data on cloud providers. They've got various, you know, nefarious means for accessing your data on these kind of server farms. Okay, so that's the background. So now let's take a look at Coursework 2. So what Coursework 2 is, it's a cloud-based data visualization website. Coursework for the spring term, so you're going to be working on this between weeks 12 and 24, weeks 12 and 23, and then the demo week 24, and it's worth 50% the marks for CST 3205. So what I'm trying to do with this coursework is show you how to build scalable websites in the cloud that can be accessed by millions of customers. Obviously, you're not going to have a website that's accessed by millions of customers. Unlikely anyway, although people will be able to access it, of course, because it's going to be on the cloud. But it's something that's potentially scalable up because, you know, you can be writing in Lambda functions or whatever. And, you know, if 1 million people access your Lambda function, I'm sure Amazon can handle that. I want to introduce you to AI techniques that use in many commercial websites. So some websites are obviously explicitly data-driven, you see the data and all that, but even websites that sell you stuff typically have a whole load of sort of machine learning and possibly even sentiment analysis running in the background. So any modern website will typically be using AI techniques of some kind to track customers and make predictions, all that kind of stuff. And so I want to introduce you to some of these techniques. Now, I'm not expecting you to learn, this is not going to teach you machine learning in any depth. There's just simply not time. It's a very complex topic. But what I'm hoping to do is show you how to use machine learning services and sentiment analysis services within the cloud that can take a lot of the heavy work out and actually produce, you know, some sensible and useful results. I want to show you how to use data from third-party web services. There's like tons of data out there that's really useful, available as web services as opposed to web scraping. And I'm going to introduce TypeScript and WebSockets. So these technologies, you're going to be using cloud data storage with DynamoDB and S3. That is if you use Amazon. I'll explain what I mean with, you know, the cloud provider options stuff. It's all going to be based on serverless in terms of how the website's going to be running. You're going to learn some stuff on machine learning and sentiment analysis and TypeScript. You're going to pull data from web services and use WebSockets. So these are the technologies that your coursework should be written in. Yeah. So you're going to build a website that displays numerical data predictions, numerical data. So you're going to hoover up some data from, let's say, Open Weather Map. Let's say you're doing a website based on London weather. Yeah. So you might pull a load of numerical data about the temperature, wind speed, and so on and so forth. From like Open Weather Map, for example, store that in DynamoDB. Then you're going to make predictions about those numerical data. So you might predict, you know, the temperature in London next Tuesday or something like that. Probably not very accurately, but you're going to make predictions about it. So that's the numerical data side. Oh yeah, so you can make predictions about it, and then you can display both the data and the predictions about the data on your website. That's the numerical data side of things, yeah? And then on the text data side of things, you're going to pull some text data. So in the weather website, this could be tweets about the weather, for example. And you're going to do what's called sentiment analysis on that data using an Amazon Web Service. And sentiment analysis determines whether it's positive or negative sentiment or feelings or emotions about that weather. So if everyone's saying the weather is great, then you have positive sentiment. And if everyone's saying, oh, what lousy weather, blah, 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 then that's negative sentiment. So you're going to hoover up some text data, do some sentiment analysis on that text data, and display the results of text data of the sentiment analysis on the website as well. Yeah. So the kind of numerical data you might use all depends on the website, but it could be product price data, stock prices, exchange rate prices, weather, football results, and so on and so forth. There's massive amounts of data available online now. And the text data for sentiment analysis, you can get it from like Twitter API, Facebook Graph, news APIs, this kind of stuff. And you're going to use machine learning to predict future values of the numerical data and synthetic. And so because the machine learning on the real data is probably not going to be very accurate, I'm also going to provide you with some synthetic data in which I know the future states of the data. Yeah, and each of you will get a separate, unique piece of data that you'll be making predictions about. So there's the real data that you're going to use machine learning on, but you're also going to display some synthetic data that I'll provide you with to check your data visualization and machine learning. You're going to store that data in the cloud using S3 DynamoDB. And then the front end of the website is going to display visualizations of the data, predictions of about the data, and the results of sentiment analysis. Don't have to do anything else, yeah? No point in having about pages or registration or any of that, yeah? And last year, and so far in this course, I haven't introduced you to this kind of idea of compiled JavaScript. So there's like various, well, for example, you might compile JavaScript if you want to use the latest features of the language in a website that might be viewed by older browsers that don't support those features, for example. But in this course, I'm going to introduce you to the compilation of TypeScript. So TypeScript is the way in which you can annotate JavaScript with the types of the variables. So you can do better stuff with numbers or other things. It's a slightly more rigorous way of writing JavaScript. So you write TypeScript, then you compile that down to ordinary JavaScript, which will kind of run anywhere. So as I sort of mentioned, we're going to be using serverless technology. So you're going to write functions, Lambda functions. Lambda functions are just individual chunks of code that run on the server, run somewhere in the cloud, and then you link these Lambda functions together by events. So an update to the database might trigger a Lambda function that processes that data, maybe does some sentiment analysis and writes the data back to the database. And then when the new data appears in the database, it could then trigger another function that sends it off to the client using a WebSocket, something like that. So the front end, you don't have to use TypeScript. You can if you want. You could compile some stuff down to ordinary JavaScript from TypeScript, but you can also just use ordinary JavaScript. And we're going to be using WebSockets to push data to subscribed clients. So with standard web stuff, you can send like a GET. It's like a stateless interaction where the client sends something to the server sends something back to the client. WebSockets allow two-way communication between client and server. So the server can push data to the client, and you're going to be using WebSockets for that here. So in this coursework and teaching and the teaching materials to support the coursework are all going to be based on Amazon Web Services. You can use a different cloud provider, but I'm only going to be able to provide limited support for that. So yeah, I've sort of mentioned TypeScript, storing data in the cloud, machine learning sentiment analysis in the cloud. So machine learning sentiment analysis has to be done in the cloud using cloud services. Yeah, not something you just hack together on your local computer. And you're going to be using serverless stuff in the cloud for the database, and then the front end in JavaScript. Yeah, so I think it's kind of obvious technologies. I'm happy to discuss different technologies if you've got proposals, but unless I've given you permission for using something completely different, you're going to get 0 marks. So please talk to me if you want to use something different from the proposed or required technologies. Yeah. So as I said, the teaching materials for this course are based on Amazon Web Services. So as I explain in the next lecture, I mean, AWS it's pretty good, right? Amazon spent a lot of money on building an enormous number of different services in the cloud. And I think they're probably the biggest cloud provider. I mean, I was looking at an article on that, a couple of days ago, and it's like, yeah, well, Microsoft might be slightly bigger in terms of, $1 more billion worth of sales or something, but most of that's driven by like Word and Office, whereas Amazon stuff is all, high quality cloud stuff. Yeah. So if you get a free trial account, which means you do have to provide a credit card, which will get charged if you use more than their thing, or use some funny service that's not covered by the free trial account. So I just got charged 5p for using SageMaker when I was fiddling around with it. So you may get charged something, but you can get a free trial account, which works perfectly, works as well as any other account. I will also provide you with an AWS student account, which works. I'll make sure the coursework works on it, but it has some irritating limitations. So the most irritating limitation is it's got like weird permissions. It just doesn't, you can't create new users or grant privileges, and it mostly works, but some things don't quite work, and it's kind of annoying. So if you don't mind the credit card thing, but this is entirely your responsibility, you've been warned, use the free trial account. But I would otherwise, if you're not sure about the credit card thing, whatever, use the AWS student account, which I'll provide you with. And you're welcome to use a different cloud provider if you want to use Google or Azure. I might be using a bit of Azure anyway for the machine learning, depending on Amazon's implementation, whether I can use Amazon Forecast, I think it's called, for the machine learning. If I can't, I'll probably use the Microsoft one. But if I'm using a different cloud provider, I can only provide, if you do decide to use a different cloud provider, I can only provide limited support, right? It's taking a lot of effort to make sure everything runs well on Amazon. and I obviously can't do that for every single cloud provider. So use a different one, but you're mainly going to be on your own when you hit bugs with permissions and all this kind of stuff. So there are marks for beautiful data visualization, but there aren't marks for, pointless stuff like registration, login, and all that. Don't worry about cross-browser compatibility. You probably should have taught it by now, but let's focus on the hard stuff, not getting it to run on old versions of Internet Explorer. And again, don't panic if you've got some minor bugs, and don't always submit code functionality you've attempted, even if you didn't get it fully working. And I can always give you some marks for attempting functionality, even if it's got a minor bug that breaks it. Okay, so the support available for this coursework is the usual laboratory sessions, Q&A sessions, and the Q&A sessions. So I always recommend you come to the laboratory sessions. It's a chance to have like a one-to-one chat about your work and see what you're doing and make some suggestions. So please come to the laboratory sessions. The Q&A sessions are optional, but if you're struggling with this course, you really should come to the Q&A sessions. The Q&A sessions are a chance to fill in some of the gaps of areas not covered by the lectures. I can do some live demos. If there's no questions or anything like that, then I can actually give you a bit of one-to-one support as well. So strongly recommend that you come to the Q&A sessions if you're struggling with the course. So some people last term skipped the Q&A sessions and were struggling with the course, and then they got behind and it all became very difficult for them to catch up. Yeah. So if you're having trouble learning on your own, come along to the Q&A sessions and I can help you, yeah? And of course, there's only 26 hours of labs this term. You're going to have to work on your own time. And I strongly, strongly recommend you spend, let's say 5 hours minimum each week on this coursework, yeah? Because you've got a lot of things you've got to do this term. And there's no sort of extra 2 weeks of work over Easter break, because Easter happens after the end of term, after the submission deadlines. So you've got all your final year project, you've got the other 2 modules you're doing, and you've got this module, and if you leave this for a couple of weeks, you're going to get behind, and it's going to really be challenging to catch up, shall I say, yeah? So give this some serious time each week, at least 5 hours, or more preferably. Okay, so I'll give you a few examples of the sort of thing that I'm expecting you to produce here. So these are websites that are similar to the ones of Coursework 2. So this is a standard stock trading website showing you prices over time and sort of fluctuations, buy and sell, and that kind of stuff. Then this is a nice website. This is my sort of top example of a website that you could build. Yeah, so it's kind of simpler than all this kind of stuff. It's just showing you the crypto prices, in a graphical format over time. And I think that I haven't sort of systematically tested it, that it's got this kind of live update thing, so you can see the prices changing dynamically in live. So I'll demo that in a sec. And then we've got these kind of nice websites with kind of maps. So you kind of click on a particular area of London and it gives you like the property prices and how the prices have changed over time and all this kind of stuff. And similar things with crime data. So, if you click on a particular part of London, it tells you, how much, criminal damage and, violence against the person has been committed in the area and how those statistics have changed over time. And you don't have to stick to the sort of conventional, graph, a sort of presentation of standard data sets like crime, traffic, and so on. So, right. You can do something a bit more wild, right? So as long as you've got the data for it, you're welcome to do a different kind of project entirely. So this is a nice sort of visualization of the history of Bruce Springsteen. This is part of this whole sort of beautiful data movement. So I think they pulled a load of data off Spotify and then produced this sort of very nice kind of visualization of his songs and the popularity of his songs and so on and so forth. Yeah, so as long as you can get some kind of numerical and text data about a topic, then you can base your website on that data, and you can present that data in lots of different ways. It doesn't just have to be this kind of rigorous, graph or map format, right? You can do something that's a bit more out there. And there's lots of, if you go to much art stuff, there's tons of art projects or artworks based upon the visualization of data in different ways. So there was even a beautiful data exhibition or database exhibition at Somerset House a few years ago. So, and I went to some computer art thing a couple of months back, and again there were several works that visualize data in different ways. So if you're interested in more the sort of artistic or creative side of this, you don't have to limit yourself to displaying crime data. Yeah, you can show things in different ways. Yeah, and I'll give you credit for that in the marks. So these are the kind of good websites. Yeah, But you'll find that many more ordinary websites, or websites have a different focus, will still contain data visualization of some kind in them. Yeah. So if we look at rightmove.co.uk, for example, we've kind of got numerical data here showing the sold properties and the average price and properties sold and all this kind of stuff. So this is a data visualization of some kind. And again, if you look holiday weather, you've got the average temperature of London, again, like some kind of fairly basic data visualization, or camel price comparison site. Again, they've got graphs of how the prices have changed over time. So in terms of the marks for, there's some marks for website quality. So if you're doing something like this, or this, then that you're going to get a high mark for website quality. Yeah. If you're doing something that's more on the level of, a very basic graph of a single time series, then you're probably going to get, 1 mark, 2 marks max, for data quality. So this is for website quality. These are kind of at the lower end of the website quality in terms of data visualization. So let's have a little look at a couple of demos. So, okay, so here's the Crypto Watch one. So I think it's updating live, but you can see anyway that you've got all the different cryptos here. Their prices fluctuating over time. Very nice design. Simple but very effective. Yeah. So if you produce something like this, you can get a high mark for website quality, and the same goes for you see them updating like that. Yeah, pretty nice, I have to say. And then here's like the we've got Barnet here. Well, it's refreshing here. So here you can select different boroughs. So let's pick Barnet, right? Very topical, and then you can see the kind of graph of the crime over time, whatever, and maybe even select unique statistics here, perhaps, whatever. Anyway, you can interact with the data and see different visualizations of it, which is what I thought was quite nice about this. So you can do a map format combined with a graph format, or you could even display your predictions about data in some map with some timelines, something like that. Yeah, there's many possibilities for all this. Let's get back to my presentation. Okay. So to build this project, you're going to need some data sources. So you need some numerical data and some data for sentiment analysis, and text data for sentiment analysis. And you must download this data from a third-party web service. Okay, manual entry, not going to get any credits for that, and you're not going to get any credit if you just use web scraping. So no marks for web scraping in Coursework 2. You have to use a web service. Okay, web services are actually much easier than web scraping, and lots of them provide free data. You all know JavaScript, JSON, manipulating stuff in JavaScript. This should be absolutely trivial to get this data from web services and upload it to the cloud. Some of these data sources will require a registration. Most of them have like a free tier account where you can make like 500 calls per day to the web service or something like that. And so you might have to register with them, and then they'll give you an API key which you use to authenticate yourself with a web service. But it's all pretty easy stuff, yeah? So, some sources of numerical data, you can get like stock data, you can get weather data, you can get traffic data, football data, price data at Tesco's, foreign exchange rates, and so on and so forth. Think of what you'd like to make your project on, and I'll bet you can find a source of numerical data that will support your project. And part of the work of coming up with your proposal will be looking for appropriate sources of numerical data. And sentiment data has to be data that contains either positive or negative sentiments about a particular topic. So if you wanted to have sentiment about, some feature in the news or in the weather, then there's like this news API, which has a lot of nice stuff in it. Or we got the Twitter API. So I did a lecture a couple of years back where, showed people how to access the Twitter API. And at least 2 years ago, it was pretty easy to search for tweets on a particular topic. So you could like follow tweets on football or tweets on the weather or tweets on fishing or whatever, yeah? And Facebook Graph, I haven't tried it, but you can use Facebook Graph to access data from Facebook. And presumably you could pull the public, if your website was based on a football team, let's say, then you could pull, the latest comments on the page dedicated to that football team. I presume. I haven't tried Facebook Graph, but, that's the sort of thing you could aim to do. So again, let's have a little bit of a demo. So here we got, so the web service, just the same as any website in the sense that you've got you built web services anyway, right? But you've got the URL, right? Specify some stuff, and it gives you back a bunch of useful data, yeah? So here's a bunch of like stock data from whatever. And then you've got things that'll give you text data from, this is the news API, which looks pretty nice. I haven't bothered getting the key, but you get this, you send a GET request to that with the API key, and you get back this with a bunch of news articles, and presumably each one has an ID of some kind, so you can actually get the full bit of news there, yeah. And then you can pump this this stuff then through the sentiment analysis. Okay, so right, submission. So first thing you have to submit, as usual, is the project proposal, and deadline for that's the end of week 14, and that's worth 10% of the mark for Coursework 2. And you just submit it on the course website. The proposal must contain a brief description of the proposed website, like 1 or 2 paragraphs. It's not an essay, just a brief description, and a mock-up. So what I want you to do with this proposal is come up with an idea for your data visualization website and sketch out that idea. That's what I'm asking, yeah? A sort of vision of where your data visualization, of what your data visualization website should finally look like, yeah? So think about the kind of data visualization you want to do. If you want to do stuff like the Bruce Springsteen Life Of kind of thing, or like the crypto thing, then that's fine. Just do some kind of sketch of what it's going to look like. That's what I want. And obviously, I want you to list the sources of numerical data and source of text data for sentiment analysis. And the other thing, as I'll explain a little later, the proposal, I'm also asking you to produce a static website hosted in the cloud. So it's not hard, but I want you to get started with this cloud stuff, and that's why I want you to produce a static website hosted on the cloud. And then put all this together into a Word or PDF version proposal document and submit it on the course website. Final submission is deadline of end of week 23, worth 90% the mark for Coursework 2, and it has the project report and the source code. This all should be very familiar to you. So the project report, as usual, screenshots of the front end of the website, the data visualization. Please make sure that I can read the numbers on your data visualization, yeah? Assuming you have numbers. So I can actually check that your predictions about the synthetic data are correct, yeah? And I also want a clear description of the project. Explain the machine learning, sentiment analysis, describe how your Lambda functions work, document database, all that kind of stuff. Don't include screenshots of the cloud in the final report. Don't include screenshots of code in your final report, because I've got the code already. If you like, if it makes sense, you could do some screenshots of the AWS console, for example. So put all this into your report and submit it on the course website. Now the source code for your website are going to be probably going to include the following. You're going to have TypeScript source files for the download and upload of the data. You're going to have source code for Lambda functions, the functions running in the cloud, and you're going to have source files for the front end of your website. You know, the static stuff, yeah, the JavaScript, HTML, CSS, and all that. If you have a node modules folder, you probably won't, but if you have, don't include it, right? It's going to make your submission too large. And then, as usual, just zip it up and submit the zip file on the course website. So, you know, here's the Coursework 2. You've got the submission link there and the final submission link there. So, assessment, going to read the project reports, read the code, run some of the code, view a short demonstration of the website during laboratory sessions after the submission date. Then I'll mark the project out of 100 and scale it down to a mark between 0 and 50. The mark out of 100 is almost certainly going to be the case. But if for some reason something breaks in the cloud that no one can fix, then I might have to take that feature out of the assessment, and then I'll mark the project out of 90, say, if the feature was worth 10 marks. But it's unlikely to happen, but just as a heads up there. So mark the project using the assessment criteria. And if you want a good mark for your project, obviously you should read the assessment criteria, yeah? So maybe rewatch this part of the lecture. Make sure that you've ticked as many boxes as you can to get the maximum mark possible. And you can always get what's called formative feedback. So ask me to take a look at your website. Happy to do that. And I can give you feedback about your website and say, well, you know, roughly what's missing, what's good, what's bad, and what you need to do to get more marks for your website, yeah? So I'm often asked to do that, and it's not a problem, but obviously leave yourself enough time to fix it if you're going to ask me. Don't ask me for feedback about your website an hour before the deadline, because you're not going to have time to make any improvements. The assessments criteria there. Let's put this wrong around. Oh yeah, there they are. Yep. So assessment criteria there. And take a note of the version number. I'm going to mention this later, but take a note of the version number, because there are going to be potentially changes to the assessment criteria depending on the cloud, on how easy it is to get running on the cloud and the education accounts and all this kind of stuff. There's a number of factors that are beyond my control, and that means that I might have to modify this assessment criteria a little bit over time. So just keep an eye on the version of the assessment criteria, particularly when you're preparing your website for submission. So when you're preparing your website for submission, make sure you're comparing your website against the latest version of the assessment criteria, not the version that you downloaded just before Christmas. Yeah. Okay, where are we at? So there's the assessment criteria. So I'm just going to run through these now. So this is the project proposal. And this is, so I want you to briefly describe your proposed website. So come up with an idea about what you want to do and describe it in 1 or 2 paragraphs. One's fine. List the sources of numerical data. List the sources of text data for sentiment analysis. And I want you to do some mock-ups of what the website is, what you want the website to look like. Yeah. Showing the data visualization. So you remember the crypto website. If that's what you want your website to look like, then do a quick sort of mock-up of what that's going to look like. Yeah, you can copy images off the web to do the visualization. I don't care, but come up with a vision of your website. Yeah, of how it's all going to be. The second component of the proposal of the week 14 submission stage is a static website hosted in the cloud. So the easiest way to do this is to upload like an index HTML file to a bucket and make that bucket public. I'll show you how to do that. And this static website should contain an image, and it should also contain your name and I need to, in the proposal that you submit, I need to see the URL of that so I can check that you have actually uploaded it. Yeah. So this is my static website example. So these are the 3 things you need to include when you document this in your proposal. Make sure that all of this is here. Okay. So you've got somewhere in your proposal, I need to see this URL so I can check that your website actually exists in the cloud. I want that website ideally to have your name in it somewhere, yes, so I can know that it's your website that you've uploaded. Yes, in this case it's David Gamez data visualization website, and this website must contain 2 things. It must be the HTML file, whatever you use, but also some kind of image, just to sort of, so that you're fine with linking things together with different resources within the cloud. That's the point of that. Yeah. So 3 things: include the URL in your proposal, your name somewhere, and and some kind of image as well. Yeah. So you've got multiple resources being linked together in the cloud. So that's all the week 14 submission. And then we've got the download and storage of data criteria. So I'm expecting you to use TypeScript to download numerical data from third-party websites, services, and use TypeScript to download text data from third-party web services. And then you're going to store that data in the cloud database, and also you're going to store, so you're going to store both the numerical and the text data in a cloud database. And you're also going to store the synthetic data for machine learning in a cloud database. Okay, that's the download storage of data. 10 marks for that. Once that data is in the cloud, you're going to apply some machine learning and sentiment analysis to that. So you're going to use machine learning to generate correct predictions about synthetic data, and also use machine learning to generate correct predictions about numerical data from third-party web services. So there's no right answer about these, about the numerical data you've downloaded, because it's probably going to be noisy data. Who knows? But there is a correct answer about here. So you'll get 5 marks if you get the correct answer. You probably get half marks if you get the wrong answer. Yeah, I'll finesse that when I've actually done, figured out exactly how to do this. So just another heads up here. This is going to be probably the hardest part of the coursework here. So you might want to leave that till towards the end, or till you've done everything else. Sentiment analysis is kind of easy. You can just use a web service like Amazon Comprehend to give you back the sentiment analysis of the text data stored in the cloud. That's pretty easy. So that's the processing of the data to make predictions and do the sentiment analysis. And then I also want you to visualize the data. That's the whole point of the website, right? So you got these marks for visualizing different parts of the data, right? So you get 2.5 marks for visualizing the third-party numerical data in the cloud, 2.5 marks for visualizing the synthetic data. Then you've got marks for visualizing predictions about the third-party numerical data and the predictions about the third synthetic data, and also for displaying the results of sentiment analysis. That might be a progressive thing, right? Not just putting the raw numbers in or a JSON dump or something like that. Yeah. And there's 10 marks for the quality of the website and the data visualization. So if your website is as good as this, you get the 10 marks. Yeah, that's like a first quality website. Yeah, top quality, multiple data sources visualized in different ways. It's attractive. That's 10 marks for data visualization. Yeah. Whereas this, if you do something like this, then you maybe get 1 mark, possibly 2, possibly 0. But a very low mark for website quality, because it's just a basic graph displaying a single piece of data that varies over time. So you'll still get the marks for downloading the data, making predictions, all that kind of stuff. But if this was your project submission, you're going to get 0 or 1 maybe marks for the quality of the data presentation, because it's not half as cool as that, right? Then WebSockets, you get 10 marks for using WebSockets to push new data to subscribe clients. Again, going back to my example, I'm pretty sure they'll use WebSockets there. And the whole website's going to be hosted using serverless technology, yeah? So you're going to put these Lambda functions in the cloud. You get your 10 marks for doing that, if we're running it on Lambda functions. And you get another 5 marks if you're using events to connect Lambda functions together. You don't just have some kind of enormous single Lambda function that hosts your website. The neat and clever way to do this is to have multiple Lambda functions that work together to produce your website, yeah? So you have maybe one Lambda function be triggered by a database update, and then it will then call comprehend to do the sentiment analysis, then write the results back into another database table. That other database table will then trigger another Lambda function that will then push the data back to the client, for example, So that's kind of, it's a sort of JavaScripty way of hooking stuff together in the cloud, and so there's 15 marks for that. And then code, oh wait a minute, we already got WebSockets, ignore that. Then we've got code quality, so the TypeScript code quality, Lambda function code quality, and then project reports. So take some screenshots of the front end of the website, and data visualization. Please make the data visualization pictures high resolution so I can see what's going on, yeah. And then clearly describe the project. Don't include screenshots of code. I know what the code looks like. You can include screenshots of AWS if it seems appropriate. An architecture diagram would also be a good idea to explain how everything works together. I should have put marks in for that, but it's a bit late. So you have to demonstrate your project to us in the labs. I'm going to ask you questions, check it's your own work, all that kind of stuff, and obviously demonstrate the submitted code. Don't spend a couple of weeks working on a better version and demonstrate that, because I'm going to look at your code. It's going to be obvious it's an improved version. I'm not going to give you any extra credit for improving it. Demonstration's mandatory. You're going to receive 0 marks if you haven't demonstrated it by 5 o'clock on Friday, 26th of April. That's like a week after the Easter break. Now, many students on my courses have had severe personal problems, illness, financial problems, family problems, all kinds of stuff, and that happens to you. And at Middlesex, we appreciate and understand that. We understand that and try and help you with that, yeah? So if you have this kind of extenuating circumstances, then you can make an application for, I think it's called deferral of assessment. And that means that you can have extra time to complete the coursework, and there'll be no mark penalty at all for that. Yeah, we try and help you and support you with all that kind of stuff. So if you want to apply for deferral of assessment, you follow the details here, and you have to provide documentary evidence, and someone within the university will look at it and decide whether it's appropriate documentary evidence and whether you should be granted a deferral of assessment. And in which case they'll let me know, and you'll get the extra time to complete your project without a mark penalty. Okay, so we'll do our best to help you when you hit the problems that life throws at you. Okay. However, if you have like what I don't accept on this course is weak excuses. Yeah. So if you have a severe personal problem, apply for extenuating circumstances, but that does not apply to excuses like, I had to watch the latest Game of Thrones box set, or I slept in, or I was tired, or I was working, because you're supposed to be full-time students. None of these count as excuses. And in particular, what does not count as excuse is my laptop died and I lost all my project. I've heard that excuse many times, and I've never given anyone any kind of extension based on that. Okay, if you're working in the real world and a company, losing your data is an extremely serious thing, and losing your code is also an extremely serious thing. So it's better that you learn now that the world doesn't accept excuses like that, and you have to back up your data regularly. Okay, so you're probably going to be okay with some of your data because it's all stored in the cloud, but I recommend that you take all your source code after, say you're working on something for 2 hours and have a break. When you have that break, zip up all what you've been working on, put it on live drive, on your OneDrive with like a version number, or version number would be fine, or a date. Or sensible thing to do would be to create a Git repository and then commit it, and then you'll have all the versions of your code available if you want them, or email it to yourself if really necessary. But don't only think about how much work you're willing to lose, and then plan your backups accordingly, right? So if you're fine with losing a week's work, not recommended a course, then back up your data once a week, because you will lose it at some point. If you're fine with losing your data after 2 hours, then back it up every 2 hours. If you're fine with only fine with losing like 10 minutes of work, back your data up every 10 minutes, or work on the cloud or something. Yeah. So, think about how much of your work, time and work you're willing to lose, and then plan your backups according to that. Yeah. So don't accept excuses. The only thing I will accept is a successful extenuating circumstances application. So forget about excuses. Don't waste your time. Just hand your coursework in on time, plan your coursework, and contact me before the deadline if you run into problems. I had a couple of students contact me last term. I did my best to help them out and come up with a pragmatic plan for passing. Don't have any problem with that. But do contact me if you're having problems. I'm unlikely to give you an excuse, but I will try and I'm unlikely to give you an extension, but I will do my best to help you. Yeah. So if your submission's late, the mark's half every 24 hours after the deadline, and it hits 0 after 1 week. That's how it's going to be. So you've been told this many times, so plagiarism, serious academic offence. If you just copy someone else's project, I'll report you to the university and they'll do whatever they do. They'll probably ask you to resubmit it. They may give you some mark penalty. You may even fail your module, or in the worst case, fail your degree. Okay, just don't do it. There's also this rather complicated line between copying and collaboration. So it's great that people work together, help each other to solve problems, and then apply the solutions to their own projects. So lots of really good examples of you working together with each other in order to solve problems. Yeah, that was great. However, there was 2 students in the last term who produced a single project, modified it slightly, and submitted the modified versions as their own work. That's completely unacceptable, and you'll lose marks if you do that. Yeah. So if I have 2 projects that are obviously just a single project that's been, that's been had some minor changes to make it look like 2 projects, then I'm going to divide the mark between the projects. So suppose a project gets mark of 60% and near identical versions are handed in by 3 people. So instead of getting the full 60% for the project, they're going to get 20% instead of 60%. And when this happens, it's extremely obvious. It's usually a really bad project that 2 people have collaborated on with a really bad solutions, probably copied off the internet somewhere, and then just lightly change the name of the thing or change a couple of bits of description or something. Yeah. So, so never really, it's always obvious when you've done this, and you will lose the marks. Okay. And so if you're losing third, or you're losing half or 2/3 of a bad project, then you're going to be in real trouble when it comes to passing this course. So I strongly recommend that you just don't do this. Yeah. Or ask me if you think that you're worried that your project's too identical to your friend's project. I'll only penalise you for the bits of the project that are identical. All this information is in the coursework description document, available on the course website. Yeah, just take a note. So cloud technology is an early stage of development. AWS is running out introducing new features all the time, and the way in which they implement the features is also changing, and their educate account is also a bit, volatile, shall I say. So I may have to adjust the coursework to take into account some of the changes in the services provided by the cloud. Yeah. So do check the version of the coursework description. I've said this before, say it again. When you hand in your course, before you hand in your coursework, check that you're comparing your coursework against the latest version of this description, the latest version of the assessment criteria, because I may have to tweak it this term in response to what's going on. Yeah. Okay, so in this lecture, I've described coursework 2, and the next lecture, I'm going to introduce you to Amazon Web Services.